In this video, we're continuing section 4.2 on maximums and minimums, and we're going to focus on what happens if the min or the max is not at the vertex of our parabola. So I want to motivate this with a warm-up. So in this problem, let's let our function be x minus 9.23 quantity squared and then plus 12.86. Okay, so we got some weird decimals in here, and then it asks me which is larger. Part A is f of 4 or f of 14. Which of those is going to be larger? So there's a couple ways I could approach this. Like I could take the number 4, I could plug it in. I could take the number 14 and I could plug it in. And then I could work those out and then see which one's going to be bigger. But let's try to get a graphical sense of what's going on here. So let me draw some axes. So let's draw a y-axis. Let's draw an x-axis. Because I see that this is a quadratic and it's in vertex form. So let's label the vertex. So the vertex of this, the x-coordinate is 9.23. That's what I plug into the x to make the perfect square be 0. And if I do plug that in, well, this is 0. And then I get plus, I get plus 12.86. So that means the y value is 12.86. Okay, so at the vertex, the y value, I actually won't even label it, but the y value is 12.86. I see that there's technically a 1 here, so the leading coefficient is positive. So we have an upward-facing parabola. Upward-facing, keep erasing this, but upward-facing parabola, something like this. Then the mirror image on this side. All right, so I got an upward-facing parabola. Okay. So when we think about the numbers 4 and 14 and then plugging them into this, what's going to dictate like which is larger is if I have 2 points, which one of those is going to be further from the vertex. Like if one of the points was here and the other point was here, well, this orange point is clearly further away from the vertex than that pink point is. So the orange point is going to have a larger output. So let's try to determine that. Let's try to determine which point is further away from the vertex. So I can see that if I let x be 4, let's subtract those two values. If I do 9.23 minus 4, well, I get 5.23. So this length right here, well, that is 5.23. Okay, so let me move this a little bit further away. Okay, so that is that distance. It's about 5.23. Okay, and I'm going to label that point. If I plug in 4, I get this point right here. So what about 14? Like, is 14 closer to the vertex than 4 is, or is 14 further away from the vertex than where 4 is? Well, I can figure it out by subtracting. So 14 minus 9.23, if I subtract these, I get 4.77. Oh, so that is definitely a smaller distance. Okay, so I'm really going to try to exaggerate that. That is smaller. A distance of 4.77 away gets me to the value, gets me to the x-coordinate 14. And if I go up on the graph from where 14 is, I get this point on my parabola. But when I went up on the graph from where 4 was, I got this orange point on my parabola graph. Okay. All right, so I can see from this that clearly it's f of 4 that is larger. F of 4 is the larger one. And the reason why is, well, since it's further from the vertex. Since it's further from the vertex. Okay. And I hadn't done this before. I hadn't labeled the vertex before, but let's just go ahead and do that. My vertex was at 9.23, and we said the y-coordinate was 12.86. Okay, so the nice thing about having this visual picture is we didn't really have to plug in these numbers in and do a calculation. I could just use the shape of the parabola and figuring out, well, which one of these values is further away from the vertex to figure out the larger one. Okay, all right, now I want to do the same thing for part B. Figure out what's larger, f of 0 or f of 20. So for this, I want to give you a chance to try it first. So pause the video for 2 minutes to try this. 4, 3, 2, 1. Pause it. Pause it and try this one on your own first. All right, so hopefully you did that. Hopefully you paused it and tried it on your own. Let's talk about it together. So again, I'm going to draw the shape of my parabola. So we got our parabola graph. Something like this. And I got my vertex. I know my vertex is at the x-coordinate's 9.23. So it's at 9.23, comma 12.86. So those are the coordinates of my vertex. Okay, and we're plugging in 0. So 0's here. So clearly that distance, if I subtract these two values, oh, that's just 9.23. That one's not too bad. But if I do the 20 now, I do the bigger number minus the smaller. So 20 minus 9.23. Oh, and that's 10.77. Well, that's definitely a bigger distance. So I'm really going to try to exaggerate that in my picture. So 10.77, definitely further away. Okay, so let me put a tick mark at this point. Okay, so 20 is here. So if I go up on my parabola, x value where x is 20, I get a point here. And then where x was 0, if I go up on the parabola, I get a point here. And the point where 0 is definitely lower than the point where 20 is, because 20 is further away from the vertex. Okay, so let's write that. f of 20 is larger. F of 20 is larger since x equals 20 is farther from the vertex than x equals 0 is. That is the reason why. Okay. So this idea of identifying when a particular point is further from the vertex, that shows up sometimes in max-min problems. And in our next video, we'll take a look at an example where that happens.